So here is question number 36. Energy of uni-electron system in first excited state is minus 13.6 electron volt. This is, now we know that energy of any electron in nth state for hydrogen like atom given as minus 13.6 z square upon n square, where z is atomic number. Now for first excited state n equals 2, putting the values, E2 equals minus 13.6 z square divided by 4. E2 is given minus 13.6 equals minus 13.6 z square upon 4. Cancel out, we got the value of z as 2, which is for helium, and uni-electron system it is talking about, so helium plus. Option number 2 we have to go with. Move on to the next. So here is question number 37, everyone. In the following circuit, current flowing through Zener diode is what? The question belongs to Zener diode, which is used as voltage regulator. The Zener voltage or breakdown voltage here is 10 volt. So it will be constant always. It means across this 1500 ohm, the potential difference will be 10 volt always. Now let us calculate the total current drawn from the battery using Kirchhoff's law. 15 minus 500I minus 10 equals 0. So we got the value of I as 5 by 500, that is 10 milliampere. Total current drawn from the battery would be 10 milliampere. We have to calculate the current through Zener diode. Here the current will divide. Let us calculate the current flowing across this 1500 ohm. So I across 1500 ohm will be potential difference 10 upon 1500. That is, after solving, gets you 100 upon 15 milliampere. So the total current is coming 10 milliampere. 100 upon 15 is flowing through 1500. So rest amount of the current will flow through Zener diode. So I across Z will be 10 minus 100 upon 15 milliampere. Solving it, 150 minus 100, that is 50 upon 15. After solving, 3.33 milliampere. So this is the current across Zener diode. We have to go with option number 4, which is absolutely correct. Move on to the next. So here is question number 38, everyone. A projectile is projected from the ground with speed 30 under root 2 meter per second at an angle of 45 degree with the horizontal. At the highest point, it explodes in 3 equal parts. One part retraces its path and second part falls freely. The distance of the third part from the point of projection when it hits the ground will be what? Now let us consider these are the axes. This is the projectile we are talking about. Now at highest point, the explosion takes place and ball splits into 3 parts. First one retraces back. Second one falls freely. And third one moves with some velocity, suppose v3. Now suppose it falls somewhere here. We have to calculate this much distance. This much distance can be calculated. The range of v3, suppose this is r1, and half of the range of the starting particle, initial particle, that is r2. Now at highest point, the momentum, the linear momentum will be constant in horizontal direction because there is no force acting in horizontal direction. So since along pH the momentum is constant, or pH will be constant, therefore we can write initial momentum means before the explosion. Initial horizontal momentum before the explosion, mass into horizontal velocity, that is 30 under root 2 cos 45 degree multiplied by I cap, this is the direction horizontally, must be equal to final momentum, means momentum after the explosion. After the explosion, one particle retraces back, and since they have exploded into 3 equal parts, so m by 3 same 3 under root 2 cos 45, but minus I cap, plus second one falls freely, so it will have no horizontal momentum, 0. Third one moving horizontally with, let us consider v3's velocity, so m by 3 vector v3. Now after solving, m and this m will get cancelled out. We get 30 I cap equals minus 10 I cap plus v3 by 3. So v3 vector we have got 120 I cap. Now 120 meter per second will be the speed. Time taken for v3 to come down is now can be calculated. The maximum height or the height above the surface this v3 is will be what? H equals u square sine square theta divided by 2g. U, that is 30 under root 2 whole square sine 45 square, that is 1 by 2 upon 2 into g, and after solving we get this h as 45 meter. Now time taken for this v3 to come to the ground can be given as small t, that is under root 2h by g, which can be written as further. Putting the value of capital H, we get 3 seconds for this time. So now we can calculate this R1, that is speed 120 multiplied by time 360 meter. We have got this distance. Now we have to calculate R2. R2 will be half of initial range, that is u square sine 2 into 45 degree divided by 2g, half of the initial range, and putting the values we will get u square, that is 30 under root 2 whole square sine 90 1 upon 2 into g. After solving, R2 gets us 90 meter. So the total value or the answer which we have to calculate, that is R, will be what? R1 plus R2, that is 90 plus 360 or 450 meter. This will be the range. Looking at the option, we can say that option number 3 is absolutely correct. So we will go with option number 3 only. Move on to the next. So here is 39 number, everyone. Following configuration of gate is equivalent to. So AB, this is OR gate, gets you output A plus B. AB, this is NAND gate, gets you output A and B whole complement. Again you have got AND gate. So Y will be input A plus B and input A dot B whole complement. Now let us applying the De Morgan theorem. We have Y as A plus B dot A dot B whole bar can be written A bar plus B bar. Multiplying it, A dot A bar plus A dot B bar plus B dot A bar plus B dot B bar. A bar always gets you 0. B bar always gets you 0. So finally we have got A dot B bar plus A bar dot B as Y, and this is expression for XOR gate. So we can write Y equals A XOR B. Therefore XOR gate will be our answer. We'll go with option number 2 only. Now move on to the next. So here is question number 40, everyone. A particle executing SHM along a straight line. Choose the correct statement about acceleration. Now we know that acceleration A is given as minus of omega square x, where x can be written A sine omega t. Acceleration is time dependent. Once again, here x is the displacement from the mean position. If x is 0, A will be 0. This is at mean position. Acceleration is minimum. At x equal to amplitude, acceleration is maximum. So therefore, second option, acceleration is maximum at mean position, goes wrong. Third option, acceleration minimum at extreme position, goes wrong. Fourth option, acceleration varies with time and become maximum when particle is at rest. So at extreme position, speed of particle is 0. X is A. So therefore acceleration will be maximum. We will go with option number 4. Now move on to the next, that is 41 number.